The idea of probability is based on the observed fact that some things are random. This means that over time, relative frequencies of a single outcome seem to settle down and become a fixed value after many trials. This idea is observed when flipping a coin, for example. Out of 10 tries, you may have seen 7 heads and 3 tails, but in the long run, the results remain stable, producing approximately a 50% probability. The biggest idea about probability to understand is that chance behavior is unpredictable in the short run, but it has a regular and predictable pattern in the long run. Probability is empirical, which means that it's based on observation rather than theorizing. Probability describes what happens in very many trials, and we must actually observe many trials to pin down a probability. In the case of tossing a coin, some people have actually sat down and made thousands of tosses to prove its probability. We call something random if individual outcomes are uncertain, but there is eventually a regular distribution of outcomes in a large sample size. The probability of any outcome is the proportion of times the outcome would occur in a very long series of repetitions. We can't technically sit around and toss coins for forever, so mathematical probability is an idealization based on what would happen in an infinite amount of repetitions. A sample space is a set of all possible outcomes. Here is an example. Suppose an experiment consists of flipping a coin and rolling a die. Possible outcomes are a head followed by any of the digits 1 to 6, or a tail followed by any of the digits 1 to 6. The sample space consists of 12 outcomes. An event is any outcome or set of outcomes of a random phenomenon, and a probability model is a mathematical description of a random phenomenon consisting of 2 parts, a sample space S and a way of assigning probabilities to events. There are 2 techniques that are very helpful in making sure you don't accidentally overlook any outcomes. The first is a tree diagram, and the second technique is to make use of the multiplication principle. Here we are drawing a tree diagram to understand all the possible outcomes of a certain phenomena. Replacement is when the second draw is exactly like the first because the slips are replaced. We will go over these probability rules for the remainder of the video because they are important to understand in order to be able to grasp the idea of probability. Mutually exclusive means that events do not occur simultaneously. Complement means that given set A, the complement of A is the set of all elements in the universal set U, but not in A. Here is a Venn diagram that shows the various events that could occur. This is the general addition rule, where the set of outcomes is either in A or B. This is the addition rule of disjointed events. A or B equals P of A plus P of B. This is the multiplication rule. If it's independent, A intersect B equals P of A times P of B. If not, A intersect B equals 0. This is conditional probability. The notation is the probability of B slash A is the probability of B given A, and the calculation is the probability of B given A equals the probability of A intersect B over P of A.